Okay, so let's look at linear equations involving squares. A linear equation involving squares. So let's take a look at this example. So we have to find the value of x if 2x squared plus 4 is equal to 12. So bear in mind we are finding the value of x, not x squared, x. Alright. So the first thing here is to group like terms. Right. So we are going to have 2x squared is equal to 12 minus 4. So simply we are going to move this plus 4 to the right side and it becomes negative 4. Right. So we are going to have 2x squared is equal to 12 minus 4. 12 minus 4 is 8. So giving us 2x squared is equal to 8. Since we want to find the value of x and we are having a coefficient here, we are supposed to divide through by the coefficient. So we are dividing 2x squared by 2 and 8 by 2. So these two cancel out, these two appear, leaving you with x squared is equal to 4, right? But then the question says find the value of x, not x squared. So how do you get x out of x squared? Well, then it means that we have to eliminate this square sign up here, right? So in eliminating squares, we use the square root operation, right? So if you want to eliminate a square, you just find the square root of that particular number or variable. Alright, so what we do is we are going to find the square root of x squared and do same for the right side, because under equations, whatever you do to the left side, you have to do same to the right side. We don't want to be biased. Okay, we don't want to be biased. So once we are square rooting x squared, we have to square root 4, right? So there has to be that kind of equality, right? So whatever you do for the left, you do same for the right, for there to be a balance, right? So we find the square root of x squared and then find the square root of 4. So whenever square encounters square roots, they cancel out each other, so leaving you with only x, and then it's equal to the square root of 4. So the square root of 4 gives us 2. So this tells us that x is equal to 2, right? So simply you are going to apply the same rules that we've looked at so far, but then when you get to the point where you are left with only the variable square, now since you want to eliminate that square so that it will be left with only that variable, you would find the square root of both sides so that the square root will eliminate the square, leaving you with only the variable. And once you find the square root of one side, you have to find the square root of the other side. That is why here, after finding the square root of x squared, we also found the square root of 4, right? So that is how to solve linear equations involving squares. I believe it's well understood. Okay, let's proceed. Alright, so what if you have a square root now? So we said when you have a square and you want to eliminate the square, you are going to use the square root. So now the square root is in charge. So if you want to get rid of the square root, what do we do? Obviously we would use the square, right? So if you want to eliminate square root, you would use the square, right? So let's look at this example. So we have to solve 6 is equal to the square root of x all over 2 minus 1, right? So here we can decide to bring this negative 1 to the left side, right? So we're going to have 6 plus 1 is equal to the square root of x over 2. So here we have 7 is equal to the square root of x over 2, right? So we said that since we want to eliminate this square root, right, so this one is sort of like the x is caged inside the square root sign, right? So now so long as the x is kept in this square root sign, it is sort of being imprisoned. So it has been imprisoned in this square root sign. So it means that we can't do anything with this x, but our purpose here is to find the value of x, that is to make x stand alone, right? So it means that we have to get rid of this square root sign, right? And we said that if you want to eliminate the square root, you use the square. So you're going to square the square root of x over 2, and you're going to do same for the left side. You're going to square 7 as well. So you're going to have 7 squared is equal to the square root of x over 2 all squared, right? So that this square will take out this square root, so that this x over 2 will come out of the prison. So in the end, you're going to have 49 is equal to x over 2, just x over 2, because this square root sign has been taken away, right? The chains have been broken, so you are left with only x over 2. So 49 is equal to x over 2. So since we have a fraction or a denominator here, we can multiply it through by what? By the LCM. So here the LCM will still be 2. So I'm going to have 49 times 2 is equal to x over 2 times 2. So this 2 takes out or cancels out this 2 over here, leaving us with 98 is equal to x. Right? Therefore x is equal to 98. Right? So it is the same principle you are going to apply. The same principle. So here we move the negative 1 to the left hand side. It became plus, because we said when negative crosses the equal to sign, it has to change into what? Into plus, right? And we said that when you encounter a square root and you want to eliminate it, you are going to square both sides, right? So that is how come we squared the square root of x over 2, and we squared 7 as well. So it is the same principles that you are going to apply, right? So I would admonish you, I would encourage you to solve more examples. Solve more examples. I'm just here to give you the clue or the principles, the guidelines, right? But then it will be in your best interest to solve more examples. So like this one, you've seen an example of an equation involving a square root, right? Now it is not a guarantee that you are going to meet this same question in your examination, right? So the best thing for you to do is to pick another question or different questions that involve square roots. Try solving them and see whether you can apply the same principles that you have learned here without same question, without different question, and see whether you're going to arrive at the same answer, right? So that is one advice I would give out to you, right? So keep practicing, solve more examples, right? Solve more examples so that you perfect at it, right? So practice makes perfect, right? So the more you practice, the more you have some of these principles in your fingertips, right? All right, so let's proceed. All right, so let's now look at word problems in equations. Word problems. So there are times you will not be given an equation mathematically straightforward. Sometimes you would be given a statement, right? Statement, and you'll be asked to find the value of a particular figure or of an unknown figure, right? And you can reduce it, or you can sort of express that word problem in an equation, right? So you can express it mathematically as an equation to help you find your answer, right? So let's look at an example here. When 1 is added to a certain number and the result is multiplied by 4, the answer is 20. Find the number. Right, sorry, so yeah, it's supposed to be number, so find the number. Okay, so here you didn't see anything like 2x plus 3 is equal to 21. No, you were given a statement like in English, yeah. So you are seeing words. You thought that when you talk of math has to do with numbers. I mean, math is it's all about playing with figures. Yeah, it is true. But how come I'm seeing words? Yeah, so this is what we call the word problem. But then in math, every word problem results in a mathematical statement, right? Yeah. So it means that it behooves us to represent or to reduce this word problem into a mathematical expression, Right, so let's look at how to go about this question. It says when 1 is added to a certain number. Now you don't know that number and you're asked to find that number, right? So based on your knowledge on equations, we said that the purpose of equation is to find the value of an unknown figure or of an unknown quantity, right? And we said that these unknown quantities, usually they are represented with letters, right, which we call variables. So since you don't know that number, why not let a letter represent that number, that unknown number? So let x represent the unknown number, right? Yeah. So it says when 1 is added to a certain number. So we are going to read the statement carefully, and then we are going to represent each statement in a mathematical form, right? So let's do this together. It says when 1 is added to a certain number. So how do you mathematically express 1 being added to a certain number? Here you have let x represent that number. So when 1 is added to a certain number, so that gives you x plus 1, right? If I ask you, or if I tell you that 1 is added to 5, how are you going to write it mathematically? You're simply going to write 5 plus 1, right? So 1 is added to a certain number, and that number is what? Is x. So what is the value of 1 added to a certain number? So 1 added to x, which is what? X plus 1. Alright, so I believe you are getting the procedure, how to go about word problem systematically, right? So let's move on. When 1 is added to a certain number and the result is multiplied by 4, good. So the result, so here it means that x plus 1, right? So since we don't know the value of the x, we are going to put everything in brackets and then multiply everything by 4, because it says the result. So the result is x plus 1. So the result is multiplied by 4. So we are going to have x plus 1 in bracket times 4. So when 1 is added to a certain number and the result is multiplied by 4, okay, let's move on. The answer is 20. Now, how do you represent the answer is 20? It means that x plus 1 in brackets times 4 must be equal to 20, right? So that is how we've represented it mathematically, right? So when 1 is added to a certain number, so x plus 1, so x is a number added to 1, or 1 added to that number, so x plus 1, and the result, so x plus 1 multiplied by 4, the answer is equal to 20. Have you seen it? Yeah. So it means that we have derived an equation out of this word problem. So let's now solve our equation. So here we have to expand our bracket. So we have 4 into bracket x plus 1 is equal to 20. When we expand this bracket, we are going to have 4x plus 4 is equal to 20. We are going to move this 4 to the right side. So it's going to be 4x is equal to 20 minus 4, right? So we are going to have 4x is equal to 16. And then we are going to divide both sides by the coefficient of 4. So we're going to have 4x divided by 4 is equal to 16 divided by 4. So this 4 cancels out this 4, leaving us with x. So our x is equal to 16 over 4 gives us positive 4. Therefore the number is 4. Now let's see whether we are correct. Okay, so it says when 1 is added to a certain number, so at long last we've discovered that certain number. So that certain number is what? Is 4. So when 1 is added to 4, so what is 1 plus 4? It is 5. Okay, and the result is multiplied by 5. So it means when 5 is multiplied by 4, right? So what is 5 times 4? Okay, let's continue. The answer is 20. Is that not true? Yes, because when 5 is multiplied by 4, the answer is automatically or obviously 20. So the number being 4 is correct, right? So you see how to manipulate or to break down a word problem into a mathematical expression or a linear equation. So let's take a look at our final example. Right? So if 5 times a whole number is subtracted from 85, the result is -10. Find the sum of twice the number and 5. Wow, this is a very nice question, right? It's a very delicious question. Okay, so here too, since we don't know that number, that whole number, let y represent the number, right? So y is standing in place of the number that we don't yet know, right? Okay, so let's now take the statement one after the other and try to break them down into a mathematical expression. So if 5 times a whole number, and whenever you see the word times means multiplication. So if 5 times a whole number, what is that number? That number has been represented by x. Sorry, I'm used to x, right? In fact, we are all used to x. So here it is y. Okay, it is y. So if 5 times y is subtracted from 85, so that gives us 85 minus 5y. Now when I tell you that, or when I say that 4 is subtracted from 7, 4 is subtracted from 7, it doesn't mean 4 minus 7, it means 7 minus 4, because whatever comes after the from is a bigger one, right? So if I say 4 is subtracted from 7, it means that 7 must come first. So whatever number or figure comes after the from must appear first, right? So if 5 times a whole number is subtracted from 85, so it means 85 must come first, and then minus whatever is subtracted from it, right? So if 5 times a whole number is subtracted from 85, so here you have to get 85 minus 5y. So 5 times y, which is 5y, right? The result is, now under word problems, whenever you see the result is, the answer is, how do you represent it mathematically? That is when you bring the equal to sign, right? The result is, so I can add the result is equal to, right? So whenever you see there is, the result is, the answer is, it means equal to, right? So here 85 minus 5y is equal to -10. Find the sum of twice the number and 5. So yeah, the first thing we have to do is to find the value of this number, right? So we've gotten the linear equation here. So 85 minus 5y is equal to -10. So let's find the value of y. So simply we are going to move this 5y to the right side so that it becomes positive, right? And then we bring this -10 to the left side. So we're going to have 85 plus 10 is equal to 5y. 85 plus 10 gives us 95. So we're going to have 95 is equal to 5y. And then since we want to find the value of y, we divide both sides by 5. So we're going to have 95 over 5 is equal to 5y over 5. And 95 divided by 5 will give us 19. So 19 is equal to y, right? So you can reverse it and say y is equal to 19. Therefore our number is 19, right? Our number is 19. Now we were asked to find the sum of twice the number and 5. So this is not our final answer yet, right? This is not our final answer. Our answer is to find the value of the sum of twice the number and 5. So the sum of twice the number and 5, so it means that you have to get 2y plus 5, right? 2y plus 5. So what is y? Y is 19, right? So it means you're going to get 2 times 19 plus 5, right? And that gives us 43. So 2 times 19 will give us 38. So 38 plus 5 will give us 43 in total, right? So that is how to work with word problems. So you just take your time, you read the statements one after the other, and then try to break them down into mathematical expressions, right? And the first thing is to always represent that unknown number by a variable, right? And then you just go through the rest of the statement, and then you also try to reduce them into mathematical expressions. So in the end, you realize that you are going to get a linear equation, right? So that is simply how to work with word problems. Alright, so all said and done, at long last we have come to the end of this interesting lesson,